Good morning friends, I am from Zeal Education Society. The topic which we are going to see today is the formation of differential equation. Before going for the main topic, we will see some basic preliminaries, that is definition of differential equation, then types of differential equations, order and degree of the differential equation, solution of what is meant by the solution of differential equation, and we are going to see formation of differential equation from its general solution. Right. Now, what is meant by the first of all, starting with the differential equation, we will understood what is meant by the derivative. Derivative means we write it as dy by dx. dy by dx, here we say that d by dx is an operator which is operating on the function y, where y is some function which is depending on its value on x. So, we say that y is the dependent variable and x is here the independent variable. For example, you know that velocity is nothing but rate of change of displacement with respect to the time. Acceleration is nothing but rate of change of velocity with respect to the time. So, the quantity dy by dx, we call it as the derivative of y with respect to the independent variable x. Now, the differential equation is nothing but an equation which contains the derivatives in it. Derivatives, we also call it as the differential coefficient. Now, we will see what is meant by the differential equation. Differential equation is nothing but an equation which contains derivatives or differential coefficients in it. For example, here this equation contains the derivative of y with respect to x in it, where y is the dependent variable and x is the independent variable. Same is the case here, this equation contains the second derivative of y in it. So, all these equations are, we call it as the differential equation. Now, there are two types of differential equation we categorize depending upon the number of independent variables we have. Here, if you look at these equations, here there is only one dependent variable and one independent variable. Same is the case, that is y is the dependent variable and x is the independent variable. Whereas, if you look at these equations, that is here u is the dependent variable, but x and y, these are the two independent variables which are present in this equation. Same is the case here, x is the independent variable, also t is also the independent variable, that is u is depending on its value for two variables x and t. So, when the equation which contains only one independent variable in it, we call it as the ordinary differential equation, whereas the differential equation which contains more than one independent variables in it, we call it as the partial differential equation. Partial differentiation arises when there are more than one independent variables in it. For example, if you take want to find out area of the rectangle, it depends upon length and breadth. Now, we will see what is meant by the order of differential equation. Order of differential equation is nothing but the order of highest derivative which is appearing in the differential equation, and degree of the differential equation is nothing but the power of highest derivative appearing in the differential equation. For example, if you look at this, here this equation is d square y upon dx square raised to 3 plus dy by dx raised to 4 plus xy equals to 0. Now, if you look at this, there is a differential equation, the highest derivative is 2, that is we are differentiating y twice with respect to x. So, order of the differential equation we can say for this equation as 2, whereas the power of this highest derivative is 3. So, degree of this differential equation is 3 in this case. Here if you look at this, the order is 2 and degree of this derivative is 2. So, order and degree of this differential equation are 2. For here in this case, this is the first order first degree differential equation because you are differentiating y only once and the degree of this dy by dx is 1. Now we will see what is mean by the solution of the differential equation and how many types of solutions we have for the given differential equation. Here basically for your syllabus we have only ordinary differential equation, that is the differential equation of first order and first degree. Now solution of differential equation is nothing but it is the relation between the dependent variable and independent variable, and that relation is free from the differential coefficients. Also that relation must satisfy the given differential equation. Now look at this equation, differential equation, that is dy by dx plus 4y equals to 0. Here you know that y is the dependent variable and x is the independent variable. Now we can solve this first order first degree differential equation by writing it as dy by dx is equals to minus 4y. We combine the terms of y together on one side and combine the terms of x on another side. When we can write in this particular format, we call that format as the variable separable form. Once we obtain such variable separable form, then we can get its solution by integrating on both sides. So when you take the integration of dy by y and integration of minus 4 dx, then you know that the integration of 1 by y is log upon y, whereas the integration of dx is x, plus there is a constant of integration, that is constant c. When you take the exponential on both sides, you will get y is equals to c1 e raised to minus 4x, where c1 is nothing but the constant e raised to c. So here our solution is y is equals to c1 e raised to minus 4x. This solution contains only one arbitrary constant c1 in it. Now look, suppose we have given one particular condition, that is if we have given the initial value that at x equals to 0, y is taking its value as 2. Then if you substitute this value, that is x0 and y equals to 2 in this equation number 1, we get that 2 is equals to c1 e raised to minus 4 into 0. You know that e raised to 0 is nothing but 1. So we get the value c1 is equals to 2. And when you substitute this value of c1 in this equation number 1, we get y is equals to 2 times e raised to minus 4x. Now this solution do not contain any constant in it. So we have two solutions. One is the solution which contains one arbitrary constant in it, and other is the solution which do not have any arbitrary constant in it. So depending upon whether your solution contains the arbitrary constant in it or not, we can categorize the solutions of the differential equations as general solution and particular solution. General solution contains the number of arbitrary constants in it, and that constants are equal to the order of the given differential equation. Here your differential equation is of first order first degree, order is 1, so this solution contains only one arbitrary constant in it, whereas we call this solution as a particular solution because we are finding out the value at particular point, that is at x equals to 0, we are getting this solution. So that is why we call it as the particular solution. We have seen that the general solution contains the number of arbitrary constants equal to the order of differential equation. So if the differential equation is of order 2, the general solution will contain 2 arbitrary constants in it, and if the differential equation is of order 3, then its general solution will contain 3 arbitrary constants in it. Now we will see how to form the differential equation from the given general solution. What is its working method? So the method is very simple here. The first step is you have given some general solution which has arbitrary constants in it. So depending upon the number of arbitrary constants in it, you have to differentiate that general solution. If it contains one arbitrary constant, you have to differentiate it once. If it contains two arbitrary constants, you have to differentiate that general solution twice. Okay? So first step is differentiate the general solution according to the number of arbitrary constants which are present in it. The second step is eliminate the constant in it if any. Other than that arbitrary constants, if you have any other, then you have to eliminate that by either the substitution. And finally, we have to get the differential equation which do not contain the constant, arbitrary constant in it. So this is the working method to find out the solution, differential equation from the solution. Now we are going to see few examples to form the differential equation from the given general solution. Now consider the first example where you are given the general solution y is equals to 4 into x minus a the whole square, where a is the arbitrary constant which is present in it. Since there is only one arbitrary constant, we have to differentiate this general solution only once with respect to the independent variable, that is x. So we will differentiate both sides of this differential general solution by x. So we get derivative of y is dy by dx equals to derivative of x minus a square with respect to x is 2 times x minus a. So 2 into 4, that is 8 x minus a. So we can write x minus a is equals to 1 upon 8 dy by dx. Now we will substitute for this value of x minus a in the given equation 1. So our given equation will now become y is equals to 4 into 1 upon 8 dy by dx, the bracket square. Square of 1 upon 8 is 1 by 64. So 4 divided by 64 is 1 by 16 and it will become dy by dx the whole square. So we get here dy by dx the whole square minus 16y equals to 0. Now this is the differential equation in terms of y, where y is dependent variable and x is independent variable, and this differential equation do not contain any arbitrary constant in it. If you look at the order of this differential equation, the order of this differential equation is 1 because there is only one arbitrary constant present in the general solution. Now we go for the next example where the general solution is C1 plus C2x. So here C1 and C2, these are the two arbitrary constants present in the solution. Since there are two arbitrary constants, so we have to now differentiate this general solution twice with respect to the independent variable x. So the first derivative of this general solution with respect to x is dy by dx. Since C1 is the constant, so derivative of constant is 0, so that will become 0, and derivative of x with respect to x is 1, so we get dy by dx is equals to C2. Again we have to differentiate this equation number 2 with respect to x. So derivative, taking the derivative of dy by dx, we get d square y upon dx square equals to 0 because derivative of a constant is 0. So if you look at this equation, here there is no arbitrary constant present in it, and this is the differential equation of order 2 because there are two constants present in the general solution. If you take this example, that is the third example, it is x square plus y square equals to r square. It is the equation of a circle whose radius is r. Here r is the arbitrary constant. Since there is only one arbitrary constant, So, we have to differentiate it only once. Derivative of x square is 2x, derivative of y square is 2y, but since y is the dependent variable, we take dy by dx, and derivative of a constant, you know that it is 0. So, we have eliminated the constant which is present in the given general solution, and we have obtained the differential equation, that is 2x plus 2y dy by dx equals to 0, or you can eliminate this 2, and final solution we get it as x plus y dy by dx is equals to 0. So, I hope you have understood how to form the differential equation from the given general solution.